talk is more of like a developer perspective on UI automation testing specifically for iOS in this case. So let's see. A little agenda, what I'm going to go through today on this talk is basically like first things first, like why we need UI automation testing, why at all do it, like why. Then a bit about the tooling, what tools exist for iOS specifically, and what we can use and which tools we use internally in Trainline for these specific tasks. Third one, a bit about the problems, which kind of problems we faced, how we managed to solve them, what we've done, how we deal with UI automation in total. A bit about the approach, that's like, again, how we solve the problems. Again, sorry for repeating myself. Something about mocking and stubbing. So we use our internal solution for creating the data snapshot for the app to be able to test on. So we use real data as well, real services, but we tend to use for most of the scenarios and the tricky scenarios some stub data. So we can mock whatever situations we can and whenever we can imagine to test the app. And a little bit about analytic testing. So it's like, because the app is quite huge, we have a lot of data coming through. We use a lot of analytics tools to combine this data and to analyze the user behavior. So we actually wanted to do some testing on it. So how we send these things, are we sending the correct data? Are the data get sent when user actually do something on screen? Because that scenarios is usually missing from the testing perspective. Or someone have to do it manually using Charles or whenever network tool to monitor that. And what is our plans? What our plans about these tools? What we're gonna do with them further on and stuff like this. So let's start from first basic question: why automation testing? Why we need to do it? First of all, I would say it shouldn't be the question at all. That's quality. That's what app needs. That's like, you know, if you don't have your automation, you're missing a lot of quality monitoring on top of your app, or you do a lot of manual regression testing using this huge bundle of books like manual regression test, which takes weeks to pass before each release. So what UI automation brings, UI automation for the UI testing, it helps QA team to reduce regression testing for sure. Like we had a case when we didn't have UI automation testing, not just in Trainline and my previous company as well. It used to take a week or two just to make sure the app we're releasing is actually good enough quality to put it for the people up there. So with UI automation test, it gets reduced to a day easily, or overnight regression pack runs on UI automation. In the morning, you see result, you say, oh, okay, yeah, it's all green, let's go. It's increased application quality for sure. You can cover a lot of scenarios you kind of missing from the manual test, or you cannot easily predict, or you see the bug in the production and you say, okay, let's put the test on it so it doesn't happen anymore in future. So we know, it's gone completely. So it's increased quality a lot. It's increased the confidence of the developers to do the change, first of all, because when you know that you have tests around the application, so you can do some change, do some refactoring, and making sure like nothing gonna break, that increases your confidence as a developer and increasing the confidence as like for product people as well, because when they see everything is green, everything okay, everything going fine, they know that the app we're releasing is actually good enough quality, the people will like it, it's not going to crash suddenly on something or stuff like this. It's a faster feedback on the change, so whenever someone do any change, and you don't need to wait until its QA will do full test your feature and stuff like this, because what usually we tend to do in a company, we tend to develop the test alongside with main development of the app. So whenever you finish your development as a developer, you already have a test which covers your feature, like UI-wise, like all behavioral tests and stuff like this. So when you're done, you see the green pipeline is green, so say, yeah, the work is done. So QA can do only some rough check, we call it monkey testing, just basically the scenarios, try to break the app, not just, by the book, taking the steps and try to test the things. And it's faster feedback. Whenever you make a commit, CI pick this up, automatically run the CI, run the test, select it for this specific feature, and you have your feedback within an hour, how it's gone. Yeah, good. It catches the issue early in the progress. That's basically faster feedback, things quite close. Yeah, if you have some issues, you commit some code which doesn't work, or it breaks some UI test somewhere, or you push something in develop which breaks some other area of the app, you will have a feedback and catch this issue quite early because it's all automatic, it runs automatically, and things like this. You can cover bigger test scenarios, you can cover bigger features, you can cover full flow of the app from like search to the payment flow and to presenting the tickets to a user with quite easy steps and quite fast. It's also automated way of testing. Why it's better? Because it's automated. It prevents some user mistakes, which can happen even on the regression testing. People make mistakes. Automation usually doesn't. And specific case maybe for our company, we have the huge piece of work, like we call it RSP accreditation, which basically, because we're selling tickets for the people, for train tickets, we have to pass certain checks. The app is actually correct, the tickets can work on the train, and the ticket will be accepted by the conductor on the train. So that's called RSP accreditation. So how UI automation testing can help with that? We can generate a bunch of data, like output of the test, like screenshots, flows, and stuff like this, and present this to the committee so they can easily see what's going on and how this stuff works. That's about why. Hopefully, after this little introduction, you will not have this question anymore, why we should do automation tests. Yes, we should. A bit about the tooling now. There is a lot of tools exist, and the hardest question for this specific like UI automation testing things is actually choosing the correct tool for a job, because from the variety of them, you never will know how you actually go with the right approach or not. So from just brief introduction for iOS, there is only one tool which is actually a native tool for doing this. It's Apple Xcode UI tests. And the rest of them is third-party tools which a bunch of like other people invent and produce to help with this. From this list, there is a Keef, Keep It Functional. There is a Calabash, Frank, which I think is pretty much gone now from the map. There is an Appium, which is very popular for these kind of things. It uses a cross-platform from Android to iOS, so Appium is actually quite cross-platform solution. And there is now Apple Xcode UI tests. A little bit about of them. You probably know, maybe heard of some of them. So the Keep It Functional is quite old one. It's kind of looks like unit tests for the UI automation, and it sits internally in your app. You have to bundle it with the main app to run this thing, so it's quite invasive test. So you introduce the massive library inside your code for the testing, and it's kind of, you need to build separately for that. It's a bit slow and it's a bit messy. It doesn't reset your data before the tests run, so one after another. So yeah, it's a tricky one. Calabash, it's slightly different one. It's actually introduces a layer of the separation between your actual app and UI and how developers write the tests. It introduces the native speaking, like English cucumber language for the writing the test itself. So it's kind of few components over here. So you have your test specs, which is plain English written files, like given, when, then steps. So you pretty much write in plain English. And there is another bit which is implementation of those steps you write in the cucumber. That's actually a very good separation, specifically for the cases when you want to involve the whole team in this approach. And that's probably what I should mention in the previous slide. UI automation test is not just a QA effort, right? It's like a team effort. If team doesn't involve with that, that's going to fall apart quite quickly. And we had a few examples of that in the train line. We had a few examples of that in my previous company. If one or two persons doing that and none of the other members of the team is involved, it's not going to pay it out. It's going to just fall apart. It's going to make outdated quite quickly, and it's just going to be a waste of effort. So it's actually a team effort. And Calabash introduces, that was the first tool which introduced this level of like collaboration you can put in place, because the test can be written without really knowledge of any developer languages. It's just a plain English test with quite small, very simple notation, like given, when, then. You just write this beginning and then you write your steps. Like given application is launched and user taps like login button, I should see the login screen. my peers, something like that. So it's very simple. And then developers can actually put some real language, which is like, I think, Ruby. The Calabash was using Ruby for that, for implementation of the steps, where exactly magic happens. Like we say, okay, these are steps of like given application is launched. What's happened underneath is basically we try to launch the simulator, launch application into it, and like check if application is actually launched. So this operation makes it easier to get all team involvement, so developers can help maintaining the steps, with library and stuff like that. And QA and product owners, business analysts can actually write the scenarios and give it to developers, which actually very, very good thing as a source of truth for your behavior, how the app should behave. So you have like a spec, and which is actually define you how your app is behave. Quite simple. You don't need user story and whole writing that. And actually you can see in Jira, a lot of people using this type of like cucumber type of, for creating user stories. Like given I have this state, then this should happen. Frank is kind of similar to Calabash. It's probably like earlier than Calabash. Calabash done a lot of work on top of what the Frank tool does. Appium is slightly different. It uses Java. It's actually introduced the same separation. You have spec files with the test, and you have a steps files to implementing the steps. But it's cross-platform. It's still living, and it's still improving. So Appium is a very good tool if you're considering doing cross-platform tests across both Android and iOS. That can provide you that. What we found with Appium a few years back, though, it's slowness. Specifically for iOS tests, it's very slow. Like I don't know, one test was running for like half an hour. And we said, no, that's not going to work. Because we started with Appium. The first thing, I think, internal and train line, we pretty much used all of them once, at least, in the company, just like, to understand which one actually going to work for us. We used the Keef in the beginning, which didn't work. We used the Calabash after that, and then we switched to Appium. But the problem was, it was only 1 or 2 persons who actually done Appium test and was doing that for the app. So at some point, no one was looking into this test. Developers wasn't really paying attention to this test because, okay, why I should? I'm not writing them. Someone writing them, okay. Let's him deal with that. Why we care? And it fell apart. So we thought hard, like what we're going to do with that, what we're going to use, because we knew we need some quality measurement. We need to introduce something which can involve all of the developers and QA as one team and do the job for the UI automation test. So we've gone with the native tool, with Apple Xcode UI test, which made sense because by the time we done this investigation work, Apple already released this new framework, which was quite good. It's like a second generation of their Java-ish approach for the UI test they had before. So why we decided to choose Apple Xcode UI test? First of all, it's native. It's a Swift language, so developers already familiar with the Swift. Good, check. Swift is quite simple language to get into it, so we can teach our QAs to do that. Good. It's more stable than any of the other tools because it's internal, it's maintained by Apple, so it's kind of some sign of quality there, which is good, and we know that it's not going to go out of the map and Apple will actually improve it, so we can rely on it. It's not going to break every year as other tools does. Apple supports and upgrade it. Same development language as from main app, as I said. It's Swift, so it's easy. It's familiar environment for developers. You can work in Xcode. You don't need to open any other language like Ruby or Java, which most of the iOS developers hate. I know that. It's have a good documentation. You can find pretty much everything on the Apple documentation right now about this Xcode UI test, what you can use and how it works and stuff like this. And simple thing, it works. And it's quite fast, at least fast in the beginning before you actually start using it. It does have some problems, yes. None of the tools are perfect, and even Apple one does have problems. Yeah. We choose this to solve this, but yeah, I kind of start facing things. First of all, is the speed, right? When, in the beginning, yeah, it's fast. Like, you create a simple test, you run it, yeah, it's bloody fast. It takes like 10 seconds to run, perfect. But then you start adding the checks, then you start adding the new steps, then you can start adding the static checks and all those kind of things, and suddenly start being slow. Yeah, it's still faster than any other tools, yes, but okay, UI automation test is slow. And that's something we probably just need to accept, because that's the nature of UI tests. They're gonna be slow. There is no real speed up for them. because you want to make sure it runs on a real setup on your app, and it's actually going to behave as the user, kind of tick through the things and put the data in. So it's actually a good thing. It's actually not really fast. But we still have fast feedback, not faster from manual. Maintainability and reusability. That's another thing which Apple... okay, I put it this way. It's a very good tool. The Apple done really, really good job with these components, but it's very generic. So if you want some kind of reusability of this component and not type the same code all over again in each single test, you need to do some work. You need to put some effort in it, because like how it's done by Apple, you will end up copy-pasting a lot of the things, which is pretty much similar all over the place for each single step, which is not really good. It's going to be unmaintainable long-term if we just leave it like that, right? Reliability. It's reliable enough, but again, if you start copy-pasting stuff, it's quite close to maintainability, right? Because at the end of the day, if you copy-paste things, you can miss things, and it's become unreliable at some point. Again, if you're using the real data, that's another point of not really reliable test, because who knows if you run the test overnight, what's going to happen with data? We've had these cases. We run the test overnight, which runs on a staging environment, right? And there's no trains at night. Obviously, it's not. What you can do with that? So yeah, reliability is an issue. It's still unit test type of the test. So like if you look at how it's done, it's more like unit test way of writing things. You have a function, you write everything inside the function. So it's not really like scenario-based thing. So it's just, again, it's unit test, but for UI. And that's kind of weak point of it as well, because if you want to involve the whole team in QA, either you have like really good developer QA who understand the language, who understand the developer process, understand how to do the things, or you have to teach them what it means. And yeah, that's what the last point is. So the type of UI test, unit test type, is kind of a tricky one. So what we've done? So we solved most of these problems for ourselves, at least. So we've done a few things. So we created some wrappers, basically, for creating maintainability and some reusable level of things. We call it testing framework, which basically have a bunch of the wrapping functions around the Apple generic way of doing things, and created some classes like screen classes, screen structs, and basic steps. So the tests, writing the tests, it's much easier thing. So we end up of having something close to Cucumber, but within this test function. So we can write functions like when user touch button and give some kind of button identifier, and all internal magic happens within this function, and so on. So like all the steps and check functions are quite easily, and they have auto-completion. So whenever QA try to write things and you already have established library of these steps, it's quite simple job. You already start putting something then, and you have a bunch of auto-completion appears. You can choose correct one. We done in other things, we call it Stubbing service. In other things about Apple solution, it's a black box testing. So your app running actually in kind of sandboxed environment, which doesn't have access. You don't have access to the code anymore. So you run the test kind of separately from your main code. So if when you do the unit test, you can stop your networking call by simply using HTTP network, I think, or some other tools like that. So you just can intercept the call and put your data in it, and you're done. It's not the case with UI test, because you don't have access to that environment. You can't stop anything from network. So it's actually have to go somewhere external. Or you put a bunch of data in the beginning on the app launch for the all possible cases you're going to end up with this test, which is quite difficult to do in the first place. So we end up creating a little service, which sits in our internal network. It works, so you can, the app basically, we just replace the URL endpoint for the app, and it works with not with real service, but with stubbed one. And stubbed service just have a bunch of the stubbed data in it, which we can control from the test set. So whenever we launch test, first step we do is basically say, okay, the application should have this type of response, this type of data when he asks for it. And the Stubbing server will know for this app launch, I will provide this data when the app asks me to do. So it's kind of little Node.js service which sits there and just responds to the app with some mocked responses. We use the configuration framework, which is basically just external framework. We use not just for UI test, but also for other things, like for our beta builds, our release builds. We have a lot of feature toggles, like, we have a lot of test environments which we can switch between. And the conventional approach, usually developers put this as a setting bundle, just specifically for the beta release, for internal beta releases. What we done, we actually separated this stuff. We have a separate application which called configurator, which have access to the same container which apps uses for loading the configuration. So the configurator can actually change things for the main app. And whenever you next time launch the app, you have your test scenario, feature toggles in the correct position, and correct server, put it to the correct server. So the automation uses the same framework, but internally, just to change the thing. So it's less invasive. The app doesn't know about what's happening with it. Is it tested, or is it really launched on real life? So there is less chance to put something out live with some strange staging or internal data for the it's like security risks reduced and stuff like this. So it's quite a good thing. And feature toggling frameworks, which is close to the configuration one, but it's allow us to play with the feature toggles. And for the test, to say, okay, for this launch, I want to have this, and this feature on, but this feature off, so we can test specific sets of combinations of feature for this scenario. So there's few things. So now I think I can go a little bit more details about which one of which does. Already said a few words about the testing framework. So it's just abstractions of the elements matching, basically. It has a screen pattern, which is quite common for UI automation test routing. So you're not trying to imagine where you are. You have some screen designs for the specific app state, and you can provide saying, on this screen I have these elements, which already knows how to locate these elements. So you use just this screen and some basic defined steps. I'll show you a few examples later on how the test looks like. And it's simplified way of writing test scenarios. So this framework just allows you to make it much simpler for the QA and whoever want to run this. It's a kind of BDD-ish style test now. It's not anymore UI test. It's more like rapid BDD-ish style. So you can actually it's more readable. It's more English readable. So you can understand what's happening quite easily in the test. We done a little bit alert handling in there, so a bit internal things like custom checks and assertions, custom methods for interactions with elements, navigation between the screens. So we have a function saying okay, given I'm on this specific screen, and framework will know how to actually navigate to it based on the screen structures and the screen interaction, screen combinations we defined for this framework. So it's a little bit more automation help for the QA to write in this if you don't need to write all single steps to navigate to the payment screen with which is 5 or 6 screens below. You can just simply say, oh, given I'm on payment screen, and the simulator will do and framework will do all the clicks for you. Integrated stubbing as well. So it's basically the framework allows to work with the stubbing server quite easily, like stub data, check data, and things like this. So the tests look like this. Instead of what Apple gives you in the beginning, you can simply just write, given application is on leisure login screen, when user enter the text this, and then when user taps on login button, then label should exist. That's simplest test you can imagine, which is a few lines. A bit more complicated one, sorry for out layout, but again, even complicated scenario, which covers the full flow from the search to actually see the tickets on the ticket screen through the payment. It's basically on one page on the presentation. Simple enough, which usually takes pretty much the whole few screens of with the scrolling. About the mocking and stubbing. Again, as I said, it's just a little service, which quite small structure. I will just maybe run how that interacts and how it works. So it's Node.js service. I have a bunch of templates in there, and we can send the data for the templates from the test. So the test can define what data we need, and the templates will know how the response look like. So in combine those together, you have a real response. which is quite simple. Templates are quite easy to maintain. Like, I mean, it's still effort if the API changes and the backend decide to somehow change the response or do some updates for it. Yeah, you still have to maintain that. But it's still less work than go through all your JSON stubbed files and change all of them for every single scenario. How this works? So the Stubbing server is only one server. So it can work with any, in the same time with many simulators. Like we can run the test simultaneously on a number of machines on the CI, and it still works with the same Stubbing server. So what we do there, apart from changing the endpoint for the app, we also generate the unique identifier for this run, for this test, specific one, and that identifier gets all the circle. So the test runner know about this identifier, the application gets this identifier, test runner control that, and the test runner control it on the Stubbing server. So all components work with the same identifier. That's allow us to understand, okay, which actual instance asked for the data, so we can provide the correct one from the correct test. Yeah, that's a simple kind of diagram of how this whole things work. And after we've done the first implementation of that, we thought, oh, actually, that's a good thing. We can do other thing with that. We can actually test analytics because we can redirect every single call from the app to the Stubbing server, even analytics call like Adobe, Google, Facebook, any analytics call. We can redirect them. We can save them to the database or something like that. And after launch happen, the test can actually check with the server saying, okay, did this event get through to you? And the server can look into the database for this specific identifier for this run and say, yeah, actually, in the last like 10 seconds or 15 seconds, I had this number of events, and this one was in it. So we can actually test, did analytics event gone out? So we can write this test specifically for analytics. It's a good benefit. A little bit about configuration framework. So how that thing work. So we're using Xcode schemes to organize tests into the bundles. Sorry, I think actually I forgot to update the slides. We've done a little bit work since last time I've given this presentation. So we actually now using the Xcode build command, which mentioned before below. We can actually use Xcode build command to have more flexibility of the test selection. What it means is for the specific test and for specific branch, we can say, okay, run only those tests. So Xcode build command have few variations. Have build for testing and test without building. So, and the CI can use those, utilize those, and we can provide the set of the test for those commands and saying, okay, the build up once on the one box, and then distribute this bundle for the different boxes, and they can run the tests on it without rebuilding it, which saves time a lot on the regression test, for instance. If you split your regression pack into multiple little bundles, so just to speed up things and parallelize them, you don't need to rebuild up multiple times for each of this run. So you build it once on the latest check, on the latest commit, and you use that build for run whatever scenarios we have. So we use that for the running the unit test, UI test, analytics test, and all these kind of tests. They all split it in a little kind of packs. So yeah, that's a little bit outdated. Sorry about that. Yes, we use environment variables to communicate with application under the test. So we can actually pass some information on the app launch to the app, which works for the few things I don't remember from the top of my head right now, but we utilize that mechanism. Yeah, we can stop the feature toggles using the environment variables or the configuration framework. So that's what that allows us. And also passing the Stubbing server URL and GUID. A little bit about advice about what we can do, about UI tests. There is no try. You just need to start doing that. That's our experience in the company with that. So if you're not doing anything about them, they're not going to just solve themselves. So you just need to try, fail, try again, maybe fail again. So like internally, as I said already before, in the company, we pass through like three or four different tools between we actually end up on one solution. And even that solution ended up few iteration of implementation of the Stubbing server. We had like 3 versions of it and then so yeah, it's not really a question, you just need to start doing that. we have some plans about these tools, what we can do with that, because we thought, yeah, that's kind of good. It works for us. That seems very good. What we can do with them? So we say, yeah, we're probably going to open source them. We already start working on that. So this testing framework and Stubbing framework and maybe some kind of template of the Stubbing server, we'll probably try to make open source and put on some to the other people to work as well and contribute to it. We will Stubbing. We want to, because currently Stubbing server done in the Node.js, which is harder to maybe for some of the iOS developers to start picking up and contribute to it. We want to actually move it to Swift because that feels more natural, and there is a Swift for service. Why not to use that? So that's kind of our plan. We started doing something with that, at least spiking the solution. So it looks promising, but might happen soon. We want to implement some kind of tool set to make this all set up for any project. Some kind of Swift-based tool set you can run from your console, from your terminal, and that will help you to set up the test and solution. That's planned. So, yeah, that's only advice. Do you have any questions, guys?
Thank you very much.
Thanks.
Do we have any questions? Yes, let me see.
Sorry, timeline. We're quite busy right now, like internally in the company, had a lot of quite tight schedule and stuff, but I guess maybe later this year, maybe closer to summer.
Because it was an interesting talk, and I'm very much in the situation where we have unit test, we have Appium, but we don't have any Xcode test.
Yeah, it's on the list, and the work already started on that. I don't really know exact deadlines, but it's probably going to be summertime.
Cool. Any other questions? Yes? Sorry, can I squeeze through?
Thank you, Andrey. That's great. Quick question about your GUIDs and sort of injecting them into your app. So I imagine there's some compromise in your production code, sort of probably in your networking layer, I expect, to allow you to, okay, if in test environment, then query we need to get the GUID, because there would be a GUID in the live production, I wouldn't imagine.
Yeah, that's true. That's only one. That's we try to keep this to the minimum, so this invasiveness. So we have a variable which say, okay, is that automation run, right? So this build fits. Yeah, you have to build specifically for automation still. You can't release this to the app anyway, because that's still different debugging flags and things like this. And it's only one place in app, so literally just one file when it say, okay, if automation use that endpoint and append the GUID to the endpoint. So that instead of using the production URL for every single call, it's now become like endpoint of the Stubbing server, GUID, and the rest of the same URI as you usually have to the production. That's how the Stubbing server understands the path. So it uses the production URI, everything after endpoint, to understand, okay, which call is that and which template I have to use for the call. But it's utilized the same kind of data structure for the all calls, because the nature of UI test is usually there is one scenario you follow and you say, okay, I'm in this specific condition. So it kind of makes sense to have a unique model for the all templates and use that. So you have like consistent IDs across the flow, you have the consistent data across the flow, so it kind of feels quite natural and quite look like production data.
Anyone else? Cool, in that case, let's please show our appreciation for Andrey.